These are the difference between convective parameterization and non-convective parameterization. Pay attention to convection system propagation. Whether models with convective parameterization or convective allowing models performance is not well or non-consistently good. So what model products can we use to modify our forecast? We can use RMaps now. This is a new generation of rapid updating multi-scale data analysis and projection system. It is the RMaps ST subsystem based on the quick update the four-dimensional variation assimilation technique, means 4R4D and the three-dimensional numerical cloud model. A new generation of Beijing, Tianjin, Hebei 8 Doppler weather radar data, radial velocity, and reflectivity factors for rapid four-dimensional variation assimilation. Background field is real-time fusion area with more than 2,000 automatic stations of 5 minutes and short-term numeric prediction system forecast results. The 3-kilometer resolution atmospheric three-dimensional thermodynamic field and hydrometers analysis, and 0 to 3 hour approximately numeric prediction products can be provided for the Beijing, Tianjin, Hebei region with a 10-minute update cycle. These are high-resolution analysis of three-dimensional thermodynamic fields. Look at this in the left. It is the convergence and the divergence at different levels. In the middle, it is the vertical shell of surface to 6 kilometers and surface to 3 kilometers. And in the right, this is the temperature turbulence at the surface and so on. Here is a Beijing case on July 6, 2020 this year. These are synoptical observations aloft at 8 o'clock CST on July 6, 2020. Beijing is located in the northwest airflow behind the trough from the 500 millibar to the 850 millibar. So the synoptic force is weak, but pay attention to the 500 millibar and 850 millibar. The green figures represent for the temperature difference between the different levels. So we see there are high temperature left rise between the 500 millibar and 700 millibar, and also between 500 millibar and 850 millibar. In the left, it is the Sunday of Beijing at 8 o'clock CST. In the right, it is the Sunday of Beijing at 14 o'clock CST. When looking at Sundays of Beijing at 14 o'clock CST, indicates CAP of 1,813 joule per kilogram. The height of the weight bulb temperature zero is 3.6 kilometers. The 7 to 6 kilometers here is from 10 at 8 o'clock to 14 meter per second at 14 o'clock. So the shear in this circulation is not very strong, but CAP is stronger than higher, which later assume the organization of thunderstorm may be multi-cell organization. After analysis of multi-cell storm development and the propagation path from afternoon to evening on July 6, 2020, the left is the real radar composite reflectivity at 7 o'clock CST on July 6. Look at the storm is located here. And the right is a convergence analysis field from IMAX now. The red circle in the indicates the convergence area. In the early stage of the multi-cell development, pay attention to the red dashed line. This is the same area. Where shows the convergence and high moisture gradient. That the storm development and propagated along the boundary layer convergence zone. Don't you think so? Then we will need to check the observations in the meantime. This is the theater overlaid with the wind flow field, which also indicates, look at this is the red box blueprint for Beijing. So the red dashed line, which also indicate where the convergence and high moisture gradient area. According to the IMAPS now, thermodynamic field and surface observation analysis. Now, can you assume where the storm developed and propagated along in the next 2 hours? 2 seconds for you to think about it. The red dashed line is what we analyzed from last 2 slides. This is the IMAPS convergence line, and this is the surface observation theater field. Don't you think so? It will develop here, and the storm will propagate along this convergence zone. Let's think about it. So we will show you the real situation. If the red dashed circle is the area you circled, where are expected to be new storm initiation. From the real observations, look at this. The middle image is at 18 o'clock, 1 hour later, and the right image is 18 o'clock 34. So the 1 hour later, new initiation storms is in the red circle. And we see storm developed and propagate along the boundary layer convergence zone. So the analysis of the 3-dimensional thermodynamic fields of high updated circle model with understanding of the thunderstorm conceptual model will help you estimate the propagation and initiation of the storms. Another case also in Beijing on August 2, 2019. We're looking at sounding of Beijing at 4 o'clock, 14 o'clock, and 20 o'clock at August 1, 2019, indicate that the CAP reduced at 20 o'clock, and the scene of 301.4 joule kilogram. The 0 to 6 kilometer share is 12 meter per second. CAP weaker than before, and the deep vertical wind shear is not high, which let us assume the thermal thunderstorm may not be expected. We're at 11:30 on August 1, there is a thunderstorm at the east of Beijing. This is a composite reflectivity overlaid on a horizontal wind field of 200 meters from IMAPS now. The red solid line is the convergence line. So where can thunderstorm be produced? Which area of convergence line we will need more materials to guess. Pay attention to the red box, the convergence line area. The convergence analysis field from MS-Now showed that the red box area are convergence area. The red shade means the convergence. In the red box, the convergence was existing from 200 meter to 1000 meter, but the sounding at 20 o'clock showed the high level of free convection before almost at 3 kilometers. So can it break the inhibition and reach the height of free convection? And other trigger elements. In the left, this is the surface station information about wind temperature, dew point, relative humidity at 20 o'clock CST. In the right, this is the same information at 11:30. Pay attention to the red circle, which represents the same place in the red box. We see that the dew point and relative humidity of the red box are changed a lot because of the high water vapor and energy advection lower the level of free convection. So the possibility of new storm was higher in the red box. Comparison with the daytime, the convergence line has been in the vicinity of the red box for a long time, but there is no water vapor and analytical conditions in the daytime. Also, from the surface observations, the high theater is located in the red dashed circle area at 11:30. Half an hour later, the red box area where are expected to be high possibility of new storm produced began to rain. The image above is the composite reflectivity overlaid on a horizontal wind field of 200 meters from MS-Now. There was new storm produced in the red box. The image below is the 5 minutes precipitation where the red box named Chaoyang district of Beijing began to rain. The above images are the convergence analysis field from MS-Now showed. Pay attention to the red circle area at 24 o'clock on August 1. The convergence analysis field from MS-Now showed that the red box circle are a convergence area. In the red circle, the convergence was existing from 200 meter to 1000 meter. Meantime, the Chaoyang have new storm in red box. So, do you have some confidence to give nowcasting that new storm will infect the red circle area? Your turn. In the left, this is the surface information about dew point relative humidity at 20 o'clock, and this is at the 11:30, so we can see from the surface station information the dew point and the relative humidity in the red dashed circle is the highest humidity area in Beijing. The outflow of the thunderstorm triggered a new storm half an hour before in Chaoyang, so you have full confidence to give nowcasting that new storm will infect the red circle area precisely. So half an hour later, look at the red dashed circle area where are expected to be high possibility of new storm initiation began to rain. So do you make the accurate nowcasting? At last, thank you all for your attention. All of you are the experts in your country. I hope my presentation maybe help you in using high-resolution numeric models on severe convective weather forecasting.